GraphDB includes connectors that let you use popular full-text querying tools on data stored in GraphDB repositories. Once one of these tools creates its own index for the data in a particular repository, you can embed that tool's query operators in Sparkle queries to perform very fast searches for patterns that standard Sparkle cannot find. In this video, we'll see how to do this with Lucene, which is included with GraphDB. We're going to have it search data about the characters in a set of Star Wars data. A full-text search engine treats data as a set of documents to index and search, and for GraphDB, each document will be the triples that make up the data for an instance of a particular type. So we need to specify the types from the data model whose instances we want treated as documents. For our demo, we'll use the class of characters from Star Wars. We also have to specify the properties whose values should be indexed for search. We'll have Lucene index the name and description of each character. Finally, we need a name for this configuration. We'll call ours Star Wars characters with no spaces. Let's create the connector. First, we'll make sure that we're using a repository full of Star Wars data. Next, under Setup, we'll pick Connectors. Note the range of search engine connectors we can select from. We're going to pick New Lucene Connector. For the type, I'll enter the URI of the character class so that Lucene treats instances of that class as documents. Instead of typing the whole thing out, I'll copy it from my text editor and paste it to make things go quicker and more accurately. The first property of this class to index is name, so I will enter that as the field name and paste the corresponding URI in the property chain field. This is called property chain because you could specify a path of property steps to find the relevant value, but we'll leave this as a one-link chain. We'll add another field in URI for character descriptions. Then we're all ready, and we can click OK. GraphDB creates the connector and index and adds the connector to the Lucene list. Let's try some queries that we couldn't have done without our new connector. The first query shows that we're using the Star Wars character connector that we created, and then the query passes along the string shmi as the Lucene query, telling the query engine to bind the results to the entity variable. The last two triple patterns ask for more information about whatever gets bound to the entity variable, its name and description. When we run this query, we see three results. The first has the string shmi in its RDFS label value, and the other two in its description. Remember, these are the two properties of the character instances that we asked Lucene to index. Let's modify this query to make it a more sophisticated Lucene search. I'll use the Lucene syntax to show that I want documents that mention both Shmi and Anakin within 8 words of each other. When I run the query, we'll see that there is only one result, but it has those two strings within 8 words of each other. This ability to use the specialized search operators that these full-text search engines offer and to use them on data stored in your GraphDB repositories as RDF triples opens up a lot of new possibilities for ways that your knowledge graphs can contribute to your applications.